Hello and welcome to today's video. We're going to talk about some of the less common laws of logic. So again, the logic laws, they're used to make complex logical equations a lot simpler. And for this video, T is going to be a tautology and F is going to be a contradiction. Quick definitions: a tautology is a logical statement that's always true, whereas a contradiction is a logical statement that's always false. So those are good things to know. So now let's think about the distributive law. And I know you've seen the distributive law before. You've probably seen it with multiplication. So let's look at an example here. What if I have 4 times 5 plus 1? How would we solve that? Well, we would distribute the 4, and then we would distribute the 4 to the 5 and the 4 to the 1, and we'd be left with 4 times 5 plus 4 times 1, right? Which is the same as multiplying, as adding first and then distributing. But we can do it this way too. There's nothing wrong with this, and we would get 20 plus 4 equals 24. So you can do it either way. But what I wanted to show you guys was this way, because that's how we do the distributive property when it comes to logic. So what we did is we multiplied. We did the sign that's here to the first one and the second one. So we did 4 times 5 and 4 times 6. And then we left what was being added right there. So the sign that was in between them becomes the new sign that separates the two equations. So that's what we're going to do here. So it's going to be, just replace the multiplication with this symbol. So now we're going to distribute that to the Q and to the R. So it becomes P and Q, then P and R. And in the middle, instead of being the addition, we're going to put what was originally between the Q and R, which is the OR symbol. So it's going to be P and Q or P and R. So that's how we do the distributive property. And now we can do the next one, and hopefully you guys can do this on your own, but let's take a look at it. So I'm going to distribute the P and the Q to the Q, so it's going to be P or Q. And then I'm going to leave the sign in the middle how it is, so it's going to be the and then it's going to be P or R. So that's it to the distributive property. It's basically the exact same thing you've been doing for years, but now we're applying it to a logical setting. Now let's take a look at the absorption laws. This is when we have P and P or Q, or P and Q. And this is just a special case of the distributive property, and notice that the P, the same proposition, is in both sides, and you're just going to end up with P both times. We could easily prove it using a truth table, but I think it's easier almost to just think about this logically. So it's P and P or Q. Well, that means no matter what, P has to be true, right? So P and then P or Q is also part of this. That's only going to be true if P is true. And then now the next one, it says P or P and Q. Again, P has to be true here. If Q is just true, the P and Q part would be false, and then it wouldn't matter there. So it ends up just being P both times. And we could prove that using a truth table. Alright, so now let's look at the next set that we're going to look at, commutativity laws. These names are probably bringing you back to when you took the math classes and learned the commutative property, the distributive property. And what's interesting is that they're really the same thing. Nothing's really changed here. Commutative property is what told us that, okay, 3 plus 2 is equal to 2 plus 3. That was the commutative property of addition, and it's the exact same with logic. So now it says P and Q. Well, that's the same as Q and P. And P or Q, that's the same as Q or P. So you can just change the order and it doesn't change anything. That's what the commutative law says. Alright, associativity. And this was the associative law that you learned earlier, and that's the one that said, okay, well, 2 plus 3 plus 5 equals 2 plus 5, or 2 plus, and then I could say 3 plus 5, something like this. So I can move around those parentheses and it's not going to change anything. So if I have P and Q and R, I could rewrite this as, well, P and Q and R. That's another way to do that. I can just move it around. And that's only if they're all the same. So notice they have to be the same sign. Just like in this, they had to be the same, they all had to be plus signs. Here they need to all be ands. Okay, so now inverse laws. P and not P. Think about this one for a second. P and not P. Well, when is that going to be true? P and not P is never going to be true. It's just a contradiction. Because I can never have P, both that be true and not true at the same time. So now P or not P. Well, that's just always going to be true, right? Because I have to have one or the other. P has to be true or it has to be false. Alright, so now conditional law. This rule says that P implies Q, that's how I read that, is the same thing as not P or Q. And really the only way we can prove this is with a truth table. There's not as much intuition behind this. So this is one you've got to memorize. So let's look at why this is true. So let's look at P and Q. Then I'm obviously going to have not P implies Q. Then I'm going to need to show not P. I should have put that earlier. And then I'm going to need to show, lastly, not P or Q. And remember, when I'm doing truth table proofs, I want to show that this column here needs to be equal to this column here. If they're logically equivalent, that has to be true. So let's take a look at this. So P, you can have true, true, false, false, and Q, true, false, true, false. So now let's take a look at our evidence for P implies Q. So P implies Q. P is true and Q is true. That's obviously going to be true there. P implies Q. P is true and Q is false. Well, if P implies Q, if P is true, Q would have to be true, so that one's going to be false. Okay, so P implies Q, and P is false, Q is true. This is one a lot of people get confused on, but this is actually true. There's no evidence to say that P does not imply Q here, because P implies Q just says that if P is true, Q has to be true. And the last one, if P is false and Q is false, there's no evidence to say otherwise there. Okay. So now not P, we're just going to put the opposite of the P, so we're going to have false, false, true, true. And now not P or Q. Well, let's take a look. Not P is false, Q is true, so it's true there. So not P is false and Q is false. Okay, so we've got a false there. Not P is true, Q is true, good there. And we're good on the last one because not P is true. So notice that this one is equivalent here. This is equivalent to this. So they are logically equivalent. And that's the conditional law. And that's something that's going to help us a lot later on. So make sure you've got that memorized. Okay. So now let's look at some examples of how these rules help us out. Use logic laws to simplify the following. Got a really complicated one here. So pause the video, maybe try this on your own. This will really test if you know the rules. So not P or parentheses P or F and not Q. Okay. Step by step. Not P. I'm going to work with that first. Remember, that's double negation. That's the same as just saying P. And I'm also going to simplify this one in this step too. So it's going to be P or F, and then instead of not Q, I'm just going to say Q. Now I'm going to try to simplify this mess in here. So I have P or F. Remember, F stands for contradiction. And that's in our symbols here. So if I have P or contradiction, that's going to go back to our identity law. So a contradiction is never true. So I have P or contradiction. That ends up just being P. So it's going to be P or P and Q. So I simplified the P or F to be just P. And this was, so the first step I did double negation. So double negation, I did that twice. And the second step I did the identity law. We talked about that in our first video on these laws. Okay, so now this step, what do I do here? P or P and Q. This is the law we talked about today, actually, but we can think about it here. P and Q on the inside. I have P or that. That's just going to be equal to P, and that's by the absorption law. So you should memorize these, but if you don't, most of them are intuitive. I would say the conditional one is not very intuitive, but the rest of them are pretty intuitive. So that's what we could simplify this to. So this whole mess of stuff can just be P, and that's just knowing your laws. So that's what's so helpful about this, and you often will have to do it on some tests or quizzes or things like that. So hopefully this makes sense. Hopefully you understand all the logic laws now. We'll get into some more practice. We'll have a video with just practice later on. So thanks for watching, and let me know if you have any questions. Have a good one.